Welcome to the discussions of the past year questions. This video, we shall take a look at the further pure 9231 2023 May June paper 21. Okay, let's take a look at the questions. A. Show that the system of equations, this is the given system of equation, does not have unique solution. So in order to show that the systems of linear equation does not have unique solution, just need to show that the determinant is equal to 0 will do. We cannot write it directly equal to 0. We need to show that it's equal to 0. So over here, what you need to do is just to take the first row. So you have a 1, and these two multiply. So you have a 45 minus the 48 minus the second element. Okay, so now take the second element, -2. Then take this and this multiply. So you get 36 minus the 42. Then plus the last element, 3. Then you multiply these two. 32 minus the 35. So over here, you get this one as -3. You get this one as a +12. You get this one as a -9, and is equal to 0. So therefore, does not have unique solution. Okay, just like that. So this will be the answer for the part A. Then now we look at the B. Show that the system of equation in part A is consistent. Okay. So consistent have two meaning. Either they have a unique solution or they have infinite solution. So infinite solution also considered as consistent. Since in part A, we already show that it cannot have unique solution. That means in order to be consistent, it must have infinite solution. So what we can do here is that we try to find out what is the solution, how to find a unique infinite solution. So change into augmented matrix from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a 1, 1, 1. This is a 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then what you need to do is just to do the row operation. The first row I remain. The second row I take the R2 minus the 4R1. Then I get 0, -3, -6, and -3. Then the third row, I just take the R3 minus the 7 R1. Okay. So -6, -12, and -6 if you minus it. Then from here, we continue further. The first row, copy down. The second row, just copy down as well. This one -3, yeah. Make a mistake. Then after that, the third row over here, I just need to take the R3 minus the 2R2. So this one you get 0, 0, 0, and 0. So you have one whole sentence. You have one whole sentence, one whole row over here, all of them equal to 0. So over here, until here, we can say that this is this one is considered as consistent because it's infinite series, infinite solution. It's infinite solution. Then conclusion, 3 plane form a sheaf. Okay, so this 3 plane, it will look something like this. 3 plane, they will intersect like this, something like that. Okay, so these 3 plane, they will intersect in the line. So this is the line, and it's infinite series. Okay, so that is the answer for the number 1B. Now we take a look at question number 2. Use the substitution z equal to the x plus y. And to convert this in order to solve these differential equations. So what you need to do over here is that the first thing is to differentiate z with respect to x. They have dy dx, so means the dy dx can be written as a dz dx minus the 1. Then from the original questions, dy dx equal to 1 plus the 3. I factorize the 3 out. Then this one, it can become dz dx minus 1. This one will become 1 plus 3z over the 3z minus 1. So if you join together, 1 plus this, then you can get 6z over the 3z minus 1. In order to solve this differential equation, we do the separable variables, 3z minus 1 over the 6z dz is equal to integrate dx. So integrate dx is x plus c. Integrate this, we just split them, become this. Then integrate again. Then you get this. Then I change the z back to x plus y. I need to settle the value c. The question gives you that when x is equals to 1, y is equal to 0, given in the question. Okay, given in the question here. So, and they want you to leave your answer like this. So have to watch carefully. This is x minus y, this is x plus y. They are two different things. So have to be careful. But what I have over here is x plus y. So how do you make it become x minus y? But first thing, we need to find the c first. So to find the c, according to the result that we have, information that we have half of 1 plus 0 minus 1 over 6 ln 1 plus 0 equal to the 1 plus c. So the c is a negative half. Okay. So c is a negative half, replace it back. Then I get this. 1 over 6 ln x plus y equal to x minus half. But since they want x minus y, I need to move this go over here. Okay. So move over here, I can only get x minus y. So over here, I need to move all my left-hand side to the right-hand side. Then I get this. Therefore, a is equals to the 1 over 6. Then this is a half, plus half. B is a positive half, and then the C is a negative half. Done. That will be the answer for the question number 2. Okay, now we take a look at question number 3A. By considering the expansion of this, where z equal to cos theta plus I sin theta, then they want you to use a De Moivre theorem to show this. Okay, so what you can do here is, first of all, we need to show an important result, which is, in general, z power n plus z power negative n is equal to the 2 cos n theta. So this result, I need to show it first. Okay. So what you need to do is, you just need to let z power n is equal to the cos theta plus I sin theta power n. De Moivre theorem says that you can make it become cos n theta plus I sin n theta. So similarly, we have a z power negative n is equal to this. So by binomial, by the De Moivre theorem, you have cos n theta minus the I sin n theta. Just need to show this result. So from here, Zn plus the Z power -1 is equal to the 2 cos n theta. We need to prove this result first. Then, now from here, power 4 is equal to the 2 cos theta power 4. You just need to change the n become 1. Then you can get this relationship. Okay. Then you have a Z power 4 plus the 4Z square plus 6 plus the 4 over the Z square plus 1 over Z power 4 is equal to 16 cos power 4 theta. Okay, so this is what we have. Then the question wanted to show cos power 4 theta, no 16 in front. So but before that, I need to settle my left-hand side. These two is in one group. These two in one group. We will be using this result. So what I can have over here, this one is supposed to be called 2 cos 4 theta plus the 4 times 2 cos 2 theta plus 6 equal to 16 cos to the power of 4. So therefore, it's going to become 1 over 8 cos 4 theta plus the 4 cos 2 theta plus 3. That is the answer for the part A, shown. Then part B, use a substitution x equal to sine theta. So usually when we see substitution, we direct differentiate whatever we have. Then since they give you these two values, I need to convert this to the corresponding limit value that we have. When x is equal to 0, 0 equal to the sine theta. So your theta is equal to 0. Then when x is equal to half, so half is equal to sine theta, then your theta is equal to pi over 6. Okay, so now we are ready. The x is equal to the cos theta d theta. So now, ready. These are the questions. Convert it to become 0 and pi over 6. This one will become 1 minus the sine square over 3 over 2 cos theta d theta. So simplify them together. This is the cos square theta power 3. This is the cos theta d theta. So actually, 3 over 2, sorry. Then this one, the whole thing here can become cos power 4 theta. Okay. So cos power 4 theta use the result that we have in part A. You have this one as a cos 4 theta plus the 4 cos 2 theta plus 3. Then just integrate. You will get this one as a 1 over 4 sine 4 theta plus the 2 sine 2 theta plus 3 theta. 0 to pi over 6. Just use your calculator. You get this one as a 3 over 8. This one is a 3 over 3 lah. Plus pi over 6. Pi over 2. Minus a 0. So I continue my answer here. So at the end, you will get this as the 9 3 over 64 plus the pi over 16. That will be your answer. Okay. Okay, now we take a look at question number 4. The integral in is defined by this. By considering the differentiations of x multiplied by x 1 plus x power 5 power n, or otherwise show that this relationship holds. Okay, so first of all, we need to follow the instructions. Just started from here. You differentiate it. So this one is a product rule. Keep the left, differentiate the right. Plus keep the right, differentiate the left. Okay. So we simplify first. You get 5n x power 5. 1 plus x power 5 power n minus 1 plus the 1 plus x power 5 power n. Okay. So over here, we can see that this is the common factor, but we don't plan to factorize it out, okay? Because in order to, if you factorize it out, then it will be multiple, it will be multiplied, it will be in a product form. If you factorize it out, it will be in a product form, okay? So this one, we don't plan to factorize it out, okay? I think just like that, no need to show. So what you need to do here, the trick is you need to try to focus on this part, okay? This part. So this part, we just make it become 1 plus x power 5 minus a 1. Then this one, just copy down. So after you make it in this way, so you can see that, okay, wait for a while. Okay, so this is the part that you have changed it to, okay, you change it to this way. Then this is considered as same thing, same base. You can expand them and multiply them, okay? So what you need to do now, after you multiply them, you get 1 plus x power 5 power n minus the 5n of 1 plus x power 5 n minus 1 plus the 1 plus x power 5 power n. So by doing this way, you can see that these two are the same base already. You can combine it together. Then we're almost there. So combine together, you get a 5n plus 1 over 1 plus x power 5 of n power n minus this. Okay, so this kind of trick is quite common when you solve the reduction formula. So over here, now you want to integrate, because in order to get in, you need to have integrations. So we need to integrate both sides. So if you integrate both sides, your left-hand side will become this. Then the in, since they want to present in in, the question say that the in is the lower limit is 0 to 1. Okay, lower limit is 0, upper limit is 1. So if you integrate both sides, oh, my apologies. If you integrate the left-hand side, you're supposed to get this. Okay, equals to integrate. I take the 5n plus 1 out. Integrate 1 plus x power 5 power n minus the 5n. Integrate of 1 plus x power 5 power n minus 1 dx. So for this part, actually, we no need to be so troublesome. We can straight away write it down that after you integrate them, it will be straight away you are getting this answer. Okay. Then this, you can write it down as a 5n plus 1 in. This one, you can write it as a in minus 1. So this one, you just need to substitute the values 1 and 0 inside. Replace them, then you will get the answer. Okay. So over here, if you put 1 inside, you will get 2 to the power of n minus a 0. Okay. 2 to the power n minus 0. Okay, so at the end, we want to show this, the relationship. We're almost there. So therefore, this is the relationship, 2 power n plus the 5n I of n minus 1 shown. Okay. Yeah, done. Let me write the hand properly. Okay, so this is the answer for the number 4A. So now we move on. By using this result, we will carry forward this result over here. So in I3. So remember in exam, if you're not able to prove the part A, you still can carry forward the result here to solve the part B. Okay, so just remember that. Okay, never ever stop trying. So I just copy the result first. Easy for me to refer. I copy the result from the top. Okay, so remember in exam, if you're not able to prove this result, you still can use this result to do the part B. So part B, they want to find I3. So in order to find I3, your n must be a 3. Okay, so we start from 3 first and see what will happen. When it's a 3, you get 16 I3 equals to the 2 power 3 plus the 15 of I2. So in order to get I3, you must get I2 first. Okay, so just change the n become 2 again. If the n become 2, then you get 11 I2 equal to 2 power 2 plus the 10 of I1. Okay, so that means in order to get I3, you must get I2. In order to get I2, you must get I1. In order to get I1, you change your n become 1. I0. So I0, I think I0 should be easier for us to integrate. What is I0? I0 is integrate from 0 to 1. X multiplied by, let me refer back. Oh, no x. 1 plus x power 5 power 0. Okay, 1 plus x power 5 power 0. So this one is 1 plus x power 5 power 0 dx. And we all know that power 0, you get a 1. So just have integrate a 1 dx. Integrate a 1 dx, you will get an x from 0 to 1. You're supposed to get a 1. Now we can put this inside here. After we get I1, then we put it inside here. After that, we put it inside here. Then eventually we can get the I3. Okay, so what you need to do is just have to be very careful. Maybe I should call this equation 1, equation 2, equation 3, and equation 4. So 4 into 3, I get I1 is equals to the 2 plus 5 over 6. I get 7 over 6. Then for the I2, okay, from the number 2, I get number 3. Number 2, sorry, number 2. From the number 2, I get I2 is equals to the 4 plus 10 times 7 over 6 divided by 11. Press the calculator, you get 47 over 33. Then lastly, therefore, from the equation 1, you get I3 is equals to the 8 plus 15 of I2 divided by 16. Then you press a calculator, you get the answer. Okay, so my answer is 232 over 176. Done. That will be the answer for the part B. Okay. Okay, so that is all for the question number 4. Now we move on to question number 5. Okay, now we look at question number 5. The matrix A given by this show that the characteristic equations A is lambda cubed minus 4 lambda square minus 2 lambda plus 48 equal to 0. So this one no shortcut. We just have to do it the hard way. Okay, so we need to find the determinant. That means it will be this characteristic equation. It will be determinant of the A minus the lambda I. Okay, just wait for a while. Oops, sorry about that. Okay, now just determinant 18 minus lambda 8, 32 5, 6 minus a lambda, 10, negative 11, negative 4, negative 20 minus a lambda equal to 0. Okay, so this is what we need to start with. Then find the determinant. So to find the determinant, just have to expand it carefully. So this one, it will be 6 minus lambda, negative 20 minus lambda, plus a 40, minus a 5, multiplied by 8, negative 20 minus lambda, then plus the 128, then minus 11 of 8 multiplied by 80. Okay, 80 and then minus a 32, 6 minus lambda equal to 0. Okay, so this is what you're supposed to show. This is what you're supposed to show. Okay, so over here, to save time, I will let you all expand it yourself. Okay, to save time, I'll let you all expand it yourself. If you do it correctly, eventually you're supposed to be able to get lambda cube minus the 4 lambda square minus a 20 lambda plus a 48. Okay, so this one you need to work it out your own. Work it out your own. Okay, do it yourself. Okay, so if you expand it correctly, then you're supposed to end up with these cubic equations. Okay, so for these cubic equations, it's a bit difficult for you to factorize the cubic equations. Okay, so however, we can use our calculator to factorize it. So the calculator will give you lambda minus 2, lambda plus 4, and lambda plus minus 6. Okay, so your lambda will be equal to the 2, negative 4, and 6. That will be your lambda. Okay, find the eigenvalue. So these are the eigenvalues. Okay, done. Part A. So now we move to the part B. Find the matrix P and the diagonal matrix D such that the A power 5 equal to the BD B power 5. BD B power BDP inverse. BDP inverse. Sorry. So we need to find the matrix P first. When the lambda is equals to 2. When the lambda is equal to 2. Okay, because we have 3 eigenvalue, right? 2, negative 4, and 6. So we just need to substitute the lambda each and every one inside here, inside this matrix to form a new matrix over here. So your A minus the 2i will give you this matrix. It will give you a bit troublesome. Okay, let me try to refer. Minus 2. So this one will be 16. This one will be 8, 32, 5, negative 11, 4, 10, and negative 22. Okay, so this one negative 4. Okay, so what you need to do, you see that this actually they are multiple of each other. Okay, they are multiple to each other. Okay, they are multiple to each other. So when we want to find the eigenvector, we will only choose the first two rows. The first row and the third row cannot be. You cannot choose the first and the second and the third row at the same time. So to find the eigenvector, okay, to find the eigenvector, so I just choose the first row and the second row. Okay, the first row and the second row. So for the first row and second row, just use your calculator, press it. Okay. So over here, I also will straight away expand them. Okay, so this one you can expand it yourself. So first one, you get negative 20 plus 44. So you get 24i minus the 24j plus the 24k. So you can see that all of them have a common factor of 24. Then you can say that your E1, your lambda 1 will correspond to E1. It will be 1, negative 1, 1. Just take the base. The base is the base. We call them the base. Okay, so the 24 can ignore. because all of them share by the common factor. So just take the base. So that is lambda 1. So now when lambda 2 equal to 4, so your A minus the 4i will equal to this. A minus 4i. Just take the original matrix, the diagonal all minus by 4. So the diagonal all minus by 4, minus 4, minus 4. Then you get 8, 32, 10, 5, negative 11, and negative 4. So for this question, you can see that no repeated wait minus by 4. 18 minus 4. Oh, sorry. Negative 4. I make a mistake. This is a negative 4. Lambda is a negative 4. I make a mistake. So this one is supposed to be plus 4. So this one plus 4, then my diagonal just now, the value here was wrong. Okay. So plus 4. So plus 4, then this one will be a 22. Plus 4, then you will get this as the 6 plus 4, 10. Then this one is a negative 16. Okay. So this is what we have. So you can see that all of them, they are not multiple of each other. So actually you can choose any two. You can choose any two. So we can choose any two to find the eigenvector. So I will choose the first two, 22, 5, 11, negative 11, and then 8, 10, and negative 4. So this one, if you expand them, you get 90i minus a 0j plus the 180k. So you can see that actually this one can take the 90 out, you get a 102. Therefore, your E2, your second eigenvector, will be a 102. Okay, so we'll do the same thing for the lambda number 3. Lambda number 3 is a 6. So again, you put the lambda inside, you get minus 6i. So all your diagonal minus 6. All your diagonal minus 6. Okay, then this one, it will be 32, 832. Okay, this one is 10. This one is a 5, negative 11, and negative 4. Okay, so this is what we have. So now we want to find the eigenvector. So again, as well, none of them are parallel or multiple to each other. So you can choose any two as well. So I choose the first two. Okay, so we just expand them properly. You get negative 20i minus a 40j minus a 40k. Take the negative 20 out, you get a 1, 2, 2. 1, 2, 2. So therefore, your E3 will be 1, 2, 2. So please take note that the lambda 1, lambda 2, it can be any order. The lambda 1, lambda 2, lambda 3 can be any order. Okay, so for my case, my lambda 1 is a 2, my lambda 2 is a negative 4, my lambda 3 is a 6. So, but for your case, maybe your lambda 1 will be a 6, your lambda 2 will be a 2, lambda 3 will be a negative 4. That doesn't matter, okay? As long as when you arrange them, make sure you arrange them with the correct, or the order that you decided. Okay, so for my case, my P will be the E1, E2, and then E3. Okay, so my P will be E1, E2, and E3. Okay, so E1 it was 1, negative 1, 1. My E2 is E2 just now was a 102. My E3 is a 122. This is a 2. But my D will be a bit troublesome. My D is actually A power 5. Okay, so according to the formula, we know that this is the D. We're looking for the D. Yeah, actually, this D, in our, if you refer to the formula by right, the formula is supposed to be like this. Okay, if you have A power n, will be the B D power n B inverse. But the D over this one, they make it become a D. So that means we need to make a diagonal here, power of the 5. We need to make it become power 5. So our D, it will be actually the diagonal that we have, lambda 1, lambda 2, lambda 3, 0, 0, 0, 0, 0, 0, and then you power of 5. That is your D. So power 5, you just expand them, 32, 0, 0, this one, negative 4 power 5. Negative 4 power 5 will be negative 1024. 6 power 5. 6 power 5, press the calculator, 776. 6 power 5. Let me confirm. 6 power 5. Oh, 7776. Okay. Okay. So that will be the answer for the B and D, for the part A. Okay, the B and the D, just like that. So, all done. So this will be the answer for the question number 5. Okay, now we take a look at question number 6. Find the particular solutions of the second order differential equations given that when t equal to 0, x equal to dx dt equal to 0. So this is a second order differential equations. So first of all, we write down the left hand side, the differential equation. We write it out. That is equal to 0. So from here, we convert them to the auxiliary equations. AE is auxiliary equations. Then you make it become m squared minus a 12m plus 36 equal to 0. And you get m minus 6 square equal to 0. You have m equal to 6 and m equal to 6. You have a repeated root. So if you have repeated roots, then your complementary function, okay, your complementary function xc will be equal to the at plus b multiplied by e to the power of 60. Okay, then to find the particular integrals, you just let your xp equals to, this is a trigo of sine, then we just make it become p cos t plus q sine t. So from here, I need to differentiate it 2 times. First time, I get negative b sine t plus q cos t. Then the second time, I get negative b cos t minus the q sine t. So just substitute them inside this over here, and I'm supposed to let it equal to the 37 sine t. So I get negative b cos t minus a q sine t minus a 12 of the negative b sine t plus q cos t plus the 36 of p cos, in more space, plus a 36 p cos t plus q sine t. And I'm supposed to equal to the 37 sine t. So what I need to do now is to do the grouping, all the sine group together, all the cos group together. So if you group all the sine together and all the cos together, for the cos, it will be negative b minus a 12q plus 36b cos t plus for the sine, it will be a negative q plus 12b plus 36q sine t. Then it will be equal to the 37 sine t. So what you need to do is compare. By comparison, For the cos d, there is no cos d there, so that means that 35b minus a 12q will be equal to 0. Okay, then I will get q is equals to the 35 over 12b. That is my equation number 1. Then now you compare the coefficient for sine t. It will be 35q plus a 12b is equal to 37. That will be your second equation. 1 into 2. So 1 into 2, you get 35 of the q plus a 12b is equal to 37. So from here, you can find your b as a 37 or 12 over 37. Okay, your b will be your b will be 12 over 37. Then put it back to the equation number 1. Your q will be 35 over 37. So you have found the p and q for the particular integrals. So our general solution, x is equal to the xc plus xb, and it will equal to the at plus b e to the power of 60 plus the 12 over 37 cos t plus the 35 over 37 sin t. Okay. But we haven't finished yet because we need to find the value a and b. They give you when the t is equal to 0, what is the x and the dx dt. So in order to do so, we need to differentiate it. First, dx dt, keep the left, differentiate the right. Plus keep the right, differentiate the left. And this one differentiate. Okay, so this is what we have. Then given when x is equal to 0, or when t equal to 0, not x equal to 0, x equal to the dx dt equal to 0. So from the first equation here, you will get 0 equals to the b plus 12 over 37. Then the b is equal to negative 12 over 37. Then for the second equations, you are having 6b plus a. 0 is equal to the 6b plus a minus a 0 plus 35 over 37. So by using the value b, okay, from the value b that we have, then we're supposed to get that the a is a 1. Okay, by substitute the value b here, then you can get the a is equal to 1. So this one I leave it to you. So you found the a equal to 1. So therefore, your final answer, your x will be the ad plus the b, 12 over 37, multiplied by e to the power of 60, plus 12 over 37 cos t, plus the 35 over 37 sin t. That will be your final answer for these equations. Okay. Okay, now we look at question number 7. A. Use a substitution to find this. So they mention substitution. We just follow the instruction. The very first thing you need to do for substitution is to take the substitution and then you differentiate it. So this is an x, dx. So we will change them in the form like this. Half du equals to the x dx. Okay, we just separate it from here. Just do the cross multiply. Just do the cross multiple will do. So now from here, integrate this. So you can see that I have x dx, I have x dx. I can make it become half du. So this one, it will become 1 over the square root of u and half du. So this one is actually a half u power negative half du. Integrate this, you will get u power half plus c. So change the u back and you get the answer. Just like that. Okay. So that is the answer for the part A, 7 part A. Done. Now we look at the questions. They're giving you the diagram here. The diagram shows a curve with the equations of y equals to the arc cosh together with the set of n minus 1 rectangles of unit width. Unit width means the width is 1 unit. Okay, the unit is 1 unit. So you can see 1 unit over here, all 1 unit. Okay, there are n of minus 1 of the rectangle of them. Okay, there are n minus 1 of the rectangle. Okay, so now first questions, by considering the sum of the areas of these rectangles, show that this series or the inequality of this holds. So how do you show it? So for these questions, usually when they give you series over here, then this one, if they give you series over here, then this part must be the integration. So the integration will be area. The integration will be area. Okay. So the series is also area. So we need to show the relationship holds. What you need to do now is they are bigger. So this one is actually rectangle. Area of rectangle. Okay. This one is the integrations. So in order to get the area of rectangle larger than the integrations of the area, so what you need to do is considering the rectangle supposed to be, the rectangle that you have supposed to be higher than the graph. The rectangle that you have supposed to be higher than the graph. Okay, so what you need to do is the very first step is usually I will recommend you to write this function as a fx. Okay, usually we write like this. Okay, but you can see that this is ln. This is inverse hyperbolic. So you need to check the formula booklet MM19. The inverse hyperbolic can be written as ln, in the form of ln. This one will be more convenient. Change it to this form. It will be same as the form that stated in the questions. So the sum, that means what is the area for the first rectangle? The area for the first rectangle is actually F2 multiply 1 plus the second rectangle is a F3 multiply 1. Okay. We need to find the pattern first. Then plus until you plus the last one. This will be a last rectangle. So the last rectangle is what? The last rectangle, if you follow the height stated in the diagram, the height will be following the, this is the height. Okay, so it will be following the Fn. It will be the Fn. So the last one, it will be Fn multiplied by 1 is greater than the area that you integrated, the area that you integrated from 0 until n. What is the formula? The formula is arc cosh. Okay, so this is the most important relationship you need to show at the very beginning. So since all of them have a common factor 1, all of them have a common factor 1. Actually, 1, it doesn't really matter, doesn't really important to us, just because anything multiplied by 1, you'll be getting the thing itself. Okay, so we can just write it down this as the sum. R equal to 2, FR is greater than this. Yeah. Okay. But if you change it to this way, this is FR. So you need to fulfill what is stated as the questions. So we need to change the FR into this form. Okay. So we make it like this. R equal to 2. Ln of R plus the square root of the R square minus 1 is greater than this. Now you can see my left-hand side already settled. Okay. Can see that my left-hand side, I already successfully make it same as the statement given. Okay, same already. Okay, this one same already. Now we want to show the right hand side. So how do you settle the right hand side? Right hand side will be a bit troublesome. Let me copy down here. Right hand side, you need to think about how to integrate them. So what we can do here is that this is an inverse hyperbolic. So inverse hyperbolic, we need to do the integration by part. R squared minus 1. So integration by part, it will be x up cos of x minus the differentiate up cos, you get this. Okay, so by right, you're supposed to put 0 to 1, 0 to n, 1 to n, sorry. It's 1 to n. It's 1 to n. It's not supposed to be 0 to n. It's 1 to n. This is also a 1. I write wrongly just now. So substitute n and 1 inside, then you will get n. Maybe we integrate everything first. Maybe we integrate everything first before we substitute the value. And for this part is actually our part A. Okay, our part A. We already successfully integrate them. So for these questions, we can straight away change it to become x cos of x minus the square root of x squared minus 1. But in part A, I put a plus c, right? Since this is a definite integral, the plus c is not needed. Not needed. And then over here, by right, we're supposed to have like this. So we substitute the value n and 1 inside. But this is inverse hyperbolic, and you can see that the form that is given is in terms of ln. So again, we need to change the cos over here to become hyperbolic. The logarithm, sorry. We need to convert the cos to become the logarithm form. It will be ln x plus the square root of x squared minus 1 plus the minus the square root of x squared minus 1. Yeah, just like that. Almost done. So let's just put n inside. You get n ln n plus the square root of n squared minus 1 minus the square root of n squared minus 1. That is the first part. Now you substitute the 1 inside. You get 1 ln 1 plus 0 minus the square root of 0. So basically the whole thing here is a 0. So what remains in the end, it will be this form. Okay, like this. Now, what remains is inside here, equal. Okay, so therefore, we have successfully shown this result. Oh, my apologies again. This one is a inequality sign. This is an inequality sign. So I'm not supposed to write it as equal. I'm supposed to write it as inequality here. But just write the inequality for first time you do, because the rest, this is equal to this is equal to this is equal to this. So we still write them equal. Just that for the very first sentence, we write inequality greater. So at the end, therefore, we have proven this relationship. Okay, greater n ln n plus square root of n square minus 1 minus the square root of n square minus 1. Shown, or yeah, shown. Done for this part. B, this is the part B. Okay, now we move on to the part C. Use a similar method to find the upper bound of this series. So what we have found just now is the lower bound. Now we want to go for upper bound. So to go for upper bound, excuse me. To go for upper bound, we need to reconstruct again our diagram. We don't want to use a rectangle higher than the graph. We want to use a rectangle that is lower than the graph. That means we're going to use this rectangle. We're going to use this rectangle. We're going to use this rectangle. Okay, so we're going to use this rectangle. Follow the pattern until you get this. So this first rectangle, it will be F1. This one is a F2. This one is a F3. And then the last one, it will be Fn minus 1. Okay. But however, your R start from 2. Your R start from 2, that means this one is not needed. This one is not needed. So just write F2 times 1 plus the, if you want to save time, no need to write times 1 anymore. Just straight away write F2 plus F3 plus until Fn minus 1. It will be less than the integrations of 1 until n cos of x dx. So this one is a repeat. This part is repeated. Just copy the result in part B, okay, from part B. Just copy the result from part B will do. So we no need to worry about this right-hand side part. So this one you can just write it down as the sum. R equal to 2. This one is until minus 1 only, until minus 1 only. Okay, so it's F less than this one from part B. So from part B, we know this result is, we know part B, the result is this. Just copy down only. Okay, n ln n plus 1 oh sorry, I copied wrongly. Ln n plus the square root of n square minus 1 minus the n square minus 1, if you copy the result. So, but this, the series is start from until n. So we need to, what you need to do now is from here, you plus from here, you plus Fn. So in order to remain balanced, this one you must also plus Fn. Okay. So that means based on the previous relationship, this is what you should do. Your left hand plus this, your right hand also plus this. So for your left hand, if you plus the Fn, then your series already become, this series now can start from R equal to 2 and then can reach until n already. So this one Fr, I straight away write down Fr as the ln R plus the square root of R square minus 1. So this one still less than. So it will be n plus square root of n square minus 1 minus the square root of n square minus 1. This Fn, just change all this, change your R become n. Let's change your R become n. So you will get this. Plus the ln of n plus square root of n square minus 1. So you need to be aware that these two are the same. You can combine them together. Therefore, you can get n plus 1 ln n plus the square root of n squared minus 1 plus minus the square root of n squared minus 1. Okay, so that will be the solution. So this will be your upper bound. Okay, done for this question number 7. Now we take a look at question number 8. A. Starting from the definitions of sect and tanh in terms of exponential, prove that this relationship holds. So what you need to do is you can start from left to right, or you can start from right to left. So usually we start from left, but certain cases we need to start from right. So over here, the definitions, this is your left-hand side. Sec squared t. So over here, the definition, sec squared is actually 1 over cos. 1 over cos is this. This is the definition. So you square it, then you will get et plus e minus t square minus a 4 divided by this. Okay, so you get something like that. Expand the expression, you get e power 2t and minus plus the 2 plus the e power negative 2t minus a 4. So not enough space for me. My writing too big. So this one, the 2 and the negative 4, you can simplify it, become minus 2. Then you factorize it again, you will get e power 2t minus the e power negative 2t. Sorry, you're supposed to get e power t minus e power negative t divided by the e power t plus the e power negative t square and square. So this continue over here. This is the same as this. So this form from the formula booklet, you can actually see that this is a tanh square. This is equal to your right hand side. So proven. Done for the part A. Now we move on to the part B. Differentiations, parametric equations, differentiations of parametric equation. So we need to find the x dt and dy dt. So this one need to differentiate directly. You have a tanh t, differentiate tanh, you get sec square. So ln sec, differentiate sec, you get this one, just copy down. Sec t, just copy down, divide. Differentiate sec t, you get negative sec tanh. This is what you're supposed to have. So from here, you can see that this one can be cancelled. Then you get this one as a tanh t sec square t minus a tanh t. Okay, that is your dx dt. Now we want to find our dy dt. So dy dt is easier. 4 tanh power 3t, and then this one is a sec square. Okay. Sec square, yes. So now your dy dx is actually your dy dt divided by the dx dt. So this will be the dx dt. I factorize the tanh out. This one will be a sec square t minus 1 divided by the 4 tan cube t sec square. Okay. Sorry, my apologies. My dy dx, I reverse the order. So I supposed to write the denominator and numerator upside down. I swap the place position wrongly. Okay, so this one's supposed to be 4 tan cube sec square divided by the tan t, tan t. Then I factorize the sec square out. This was supposed to have. So, of course, you need to understand that for trigo, we know that the tangent square is equal to the secant square plus 1. Okay, in trigo, we have this relationship. Oh, sorry, I get the relationship wrongly. In trigo, we have a secant square theta is equal to the tangent square theta plus 1. So by applying Osborne rule, if you go for hyperbolic, then you will get sec square theta is equal to the 1 minus the tangent. So from here, if you apply this result, then you can see that this is actually wait for a while. This is actually tangent t. This is actually negative tangent square t. Okay, by right, it's supposed to have this relationship. So you don't need to show this in exam. Just need to understand to apply them. Just need to show this directly. Just need to show that from here to here will do lah. Okay, no need to explain anything. So there's a negative here. Take note on that. Then you can see that the tangent cube and the tangent cube, all this can be cancelled. At the end, you get negative 4 sec square. Shown. Done for this part B. Done. Okay, so that is your dy dx. So now we move on to the part C. Part C, we want to find the coordinates of the point on C with the d square y dx square equal to negative 9/2, giving your answer in the form of a plus ln b and c, where a, b, and c are rational numbers. Okay. So for the second order derivative, is actually taking from the first order. You try to differentiate it. But our first order just now in part B is actually a negative 4 sec square in terms of t. So we cannot differentiate them directly unless we apply chain rule. You put a dt here, then you put the dt here. Then you can only make it. So this one differentiate negative 4 sec square t with respect to t. You will get 8 sec negative 8 sec t negative sec t times t. dt dx is actually dy dx dt. Just now your dx dt was tan t and sec square t minus 1. Okay, so simplify them as usual. Simplify them just now. We can see that this one can be cancelled. This one you get positive sec square divided by the negative tangent. Okay, so simplify further. You can get, because sec is a 1 over cos. This is a cos over sine. sine over cos. Okay, so this one can cancel. At the end, this one will be negative a over sec square. A over sine square, sine square theta. Okay, because of this reason, then I get this answer. Okay, I don't plan to write down anymore. Just explain through here will do. So this is the answer. So not the final answer yet. This is just the beginning. D square y ds square. Okay. So now they want your d square y ds square to be negative 9 over 2. So my d square y ds square to be negative 9 over 2, which means that negative 8 over the sine square t, it will be 9 over 2. Now I think perhaps simplify them into this way is not so proper. Okay, because our later we want to find the point. Later we want to find the point. This is the x, this is the y. And when we find the x and y is based on here. They are all in terms of tan and sec. So it's better, I think, it's not a good idea for me to simplify until here. Okay, because we want to solve the solution in order to find out what is the sec t and tan t. So maybe we should remain the answer as in, no need to simplify until 8 over sine square. So maybe we can remain it like this. That means negative 8 sec square t divided by the tan square t is equal to negative 9 over 2. So you are having 16 sec square t is equals to the 9 tan square t. Okay. So if you do it until here, we will get quadratic equations. So for the just now we mentioned that the 1 minus the tan square t is equal to the sec square t, right? Yeah. So we just change it to become 1 minus the okay, we make it like this. That will be better. Okay. So based on this identity, we can change it to this form. Then at the end, we can get tan squared t is 16 over 25. That means your tan t will be 4 over 5. But with the plus minus, with the plus minus of 4 over 5, because this one is a square. So your tan t will be 4 over 5. 16. Yeah, 4 over 5. Positive, negative, 4 over 5. Positive, negative, 4 over 5. Okay, so now we want to find the x. Let me see the condition first. The d must be positive. D must be positive. So d positive, that means the tan t can only be positive 4 over 5. Because if the d is negative, then you will get negative 4 over 5. Okay, so this one, for this reason, we only take the tan t is only 4 over 5. Okay, so done with the tan t. So now that x, what is your x again? X, if you refer back to the questions, the first part, the part B, x is actually half tan square plus the ln sec t. Oh, sec t, just now, what is a sec t? Tan t is a 4, 5. Okay, so just now with the relationship again, so we're going to use this relationship quite frequent. Sec square t is a 1 minus the tan square t, right? So your sec t will be the square root of 1 minus the 16 over 25. So it will be 3 over 5. Okay, so this one just put 3 over 5. So this one is a 16x over 25 plus the ln 3 over 5. Okay. So maybe I should suggest to you that you provide this working in your solution so that they understand what you're trying to represent. So your y will be a 1 plus the 10 power 4. So this one power 4, press a calculator. Okay, just give me a while. You get 1 divided by 625. So therefore, the coordinate, the point, in terms of rational form, exact value form, will be this x and then y. That will give you the second order of a derivative equal to negative 9 over 2. Done. That will be the solution for this question number C. And that will be the last questions of this paper. Let's stop the video here.